Hey, so I was catching up with the XTDB development team earlier, and I was speaking with my colleague Dan Stone, and he mentioned that he had been working on some tooling to help improve the Clojure REPL experience when working with these gnarly Java objects deep down in the bowels of the XTDB query engine. So I thought I'd pull him away from his work for 20 minutes this afternoon and asked him a few questions about it. So without further ado, over to Dan.
So I'm in the middle of a task that involves interacting with our scan operator, which is a fairly low-level operator in the query engine that interacts with storage, right? Pulls data blocks out of storage so that query operators can do their work, like filtering and so on. And so working on some like kind of low-level I/O stuff in here, and this is new to me. I'm not familiar with this code, right? So the first thing I do to try to like understand what's going on is, perhaps like get a system running, isolate the components of interest, in this case, like sort of scan operator and the various different objects that can hang off that. And so, I kind of typically will work in a comment block, a rich comment block in Clojure. So here, like, I'm going to just sort of bring in some namespaces that I might need, set up some helpful functions that might put the system in different states. So for example, this flush chunk function here, like it's going to cause an IO event to happen that wouldn't typically happen if you just left the system alone. Somebody has to do it, or like you have to put the system in the state to do it. And basically, yeah, here we're going to like set up a node and pull out various like kind of objects that the node depends on, which are arguments to functions in this namespace, arguments to constructors of other objects. But yeah, the scan operator itself, effectively, like the result is this what's called a cursor, which is kind of like an iterator. So this is sort of like the primary object I'm interested in, my understanding. And so, yeah, I'm getting myself in the position where I can get one of those at the REPL, right, on demand, and I can get one for different states of the system.
And this try cursor itself, is that a Clojure object or a Java object?
So it's a Clojure. It's like a deftyped class, right? So generated with deftype, yeah.
Okay, cool. But the stuff it's returning is full of Java. That's the point, right?
Yeah, I mean, so try cursor is opaque. So like it's an object. I mean, it's got like it implements some interfaces. Because iCursor and iCursor is closable, right? So there's a couple of functions on there. It has some like kind of dependencies which are passed through the constructor. So it's a Java object in Clojure, right? And then the things that this depends on, of course, are also often objects, opaque things. So I'm trying in my comment block, again, like unfamiliar code base. I'm kind of on my own here, like trying to like figure this out. So, what do I need to do to grab one of those cursor objects? That seems to be the kind of entry point to all the interesting behavior that I want to kind of play with in order to build my feature or make my change. So I start off. I'm kind of monkey. I'm hacking here. Like as I grab the node, because that's going to give me every single subcomponent I might need to create a cursor. So for example, I need this watermark source object. I mean, it's not really important what these are, an allocator. So I'm just going to def those so I can use them elsewhere in my comment block. And then in my comment block, I'm going to have forms that will put the system in different states. And then sometimes forms let me inspect the states. So for example, I can query the system, just run a test query and just see what the state of the table I'm manipulating is. I can grab various like kind of lower level objects, like this emitted scan. I'm just making sure that things like my understanding of the call types and how they get passed through the emit scan call are correct. What I will try to do then is, so a cursor, to grab one of these cursors, I'm going to need to hold open a bunch of resources that have close methods on them. So another thing with comment blocks is quite nice. I want to like kind of open up the entire system so I can get the thing I need and keep it open for as long as I want, right? So I'm at my REPL like perhaps for hours with the same watermark open, and the same cursor open, and I will close them with a key press, if I need to. So I've already got this open, this watermark source. I'm not going to close it. yeah, and then so I can get a cursor. So again, I've already evaluated this, and I'm going to evaluate it again. But it's a kind of complicated chain of things that I need to set up. Then I can grab my cursor. Okay, and I have a look at the cursor. So it's quite useful in comment box sometimes to have a line just to let you just with a key press inspect something. And I could accidentally press the wrong key if I put my cursor here, right, or something like that. So it's sometimes nice. So the cursor again, it's opaque. Right, so I'm okay, well, great, I can kind of go and look at the definition, right, and try and figure out what I can do with it, how I could maybe get the fields out and have a look at the different states the fields might be in. Again, if I'm exploring, right, it's kind of difficult. I have to maybe navigate through multiple files. Perhaps I could use reflection, right, or I could use a Clojure inspector or something to kind of help me out. So what I've done, so this is part 2, Jeremy.
Well, yeah, I was going to say before.
Any questions?
What would be the first tool you reach for? If you don't have a library or something on the class path, what would you normally run to see the list of methods and fields?
Well, so there's Clojure reflect. So there's Clojure reflect is kind of nice. So that there has a reflect method. Function, and you can pass that an object instance or a class object, and it will reflect the class for you. So say I've got my cursor, right, I could reflect that, and I can get an idea of the sort. I mean, it's a big printout here, but you get an idea of the sorts of fields that would be available on the object. So that can be quite a nice namespace to be aware of.
Okay. That's just that does it one level deep, right? So you have to sort of look at each of those and think about whether there's anything in those under that field that also might be interesting.
Sure, and it's also reflecting on the class. It's telling you about the schema, but it's not telling you anything about the state, right? It's this. Okay, so this instance is in a particular state, and I might be interested in the values the fields have. So it's not useful for that kind of thing, though. You can use this to then build something that will look up the field state. But it does give you an idea of the structure. I mean, but it's not really designed necessarily for humans to kind of call it the REPL, right, and kind of get a nice printout. It's sort of useful as a tool to build other things, right? But for small classes, I mean, you can read the output. So you can use Clojure reflect. I mean, I'm not an expert on Clojure reflect or anything, and there may be other cool methods in there that I'm unaware of. But that's one way. But typically, I would say in my experience, I've been in Clojure a long time. This is an atypical environment, lots of deftypes and kind of opaque objects. It's not the norm. So I'm not super experienced to kind of navigating this kind of stuff. I'm aware there is a function called bean where if you have Java beans which have getters and setters on them, or just getters on them, you meet the beans spec, call the spec. Then you can use bean to get a map that reflects the state of a Java bean. There's also the Clojure Java.data. I'd be wrong. I think it's a library. I'm not sure if it's on the class path by default in Clojure, but I think there's a from Java and to Java library. Sorry, Jeremy, I've forgotten the name of it. But so something like Clojure.java.data or something like that.
We'll stick it in the show notes.
Yeah.
I was going to ask. So we've got certainly with this one def type. So how many def types roughly are we dealing with in this namespace?
Yeah, I mean, there's a whole bunch. So there's a whole bunch of interest when I'm doing this work. I mean, this namespace might not actually have that many. One, two. Then there is the cursor, so 3. So maybe 3 here, and there's some interfaces defined here as well. But then of course we're dependent on the states of classes that define outside of this namespace, right? So it's still it's of interest to us, when we're interacting with the system, to find out more about the states of these other objects which are not defined in this namespace. So again, that kind of when you're trying to explore a system, jumping around lots of files and so on, it's quite difficult, right? You have to have a lot of working memory or be keeping notes and things like that. It's much nicer if you can get the system to do that work for you. Bring to me, everything that I might be interested in. I'm not going to go out and kind of find it myself. So that's kind of where I want to get to. I want that kind of experience where I can almost just sit in this comment buffer and explore and I can keep track of like different forms of interesting, or like, oh, this does something cool, or this tells me something cool. That's kind of what you want to do. And this will obviously be very messy. You kind of like you change it a lot. That's fine. I mean, it's just like a scratch pad, right?
Yeah, and I mean, I see you have other files open, so it's not as if you wouldn't go back to the source code and read it, but it's like you're trying to find out the bits that are relevant to the problem at hand, basically, and it's hard to do by paging between different files. So,
it can be hard. Yeah.
Okay, and so these opaque Java objects or deftypes make it particularly hard to then get to that next level of detail, because they sort of trap the information that you're looking for.
Yeah, I mean, they might have like toString methods and things on them that help you explore them. But yeah, I mean, it's certainly not the same as a Clojure. Like Clojure structures is just totally transparent, right? They don't hold anything private. Like in terms of the information of interest. I mean, of course, they got like internally have like private fields and things, but they're kind of normally irrelevant to the problem you're trying to solve. Whereas for this, like the field state of these various objects, and also closures or reify instantiations that close over state of interest. Like maybe they close over like locals, but they might also close over like local boxes, like atoms and things that may be modified or changed when the system is manipulated. So there's a lot of information which is not transparent to you. And I mean, if you, of course, at a debugger or with print lines or spy scope or something, you can get at some of those things, right, and keep records of them, def and that kind of thing. But then I have to go to all those places and find the places I want to go to and so on. So that can take a bit more time sometimes to discover.
And then I guess in terms of how you might solve this, like the official approach then maybe to bring these objects sort of into the Clojure world, given print definitions and attach metadata or whatever it needs to be to make them look and behave more like regular Clojure things, or it's to give yourself more sort of power tools for examining the structures as they are without having to sort of in advance modify everything to decorate it to look like Clojure. Yeah.
I mean, of course, like yes, I mean, you can make the objects transparent, right? Yes, implement print method and things. And if for some objects, you can implement toString on pretty much everything, so like reifies and things like that. But then closures, I mean, again, like, are you going to use the fun, typical Clojure function form and get an athen back, and it sort of all works like normal? Or like to get a good toString, like if it closes over an atom, say, to get a good toString, you're going to have to deftype, right, and implement the function interfaces and or reify. So it's kind of expensive, right? It's going to add like kind of clunky code, and you're going to have like way more code that's nothing to do with kind of the problem. It's just sort of there to help you not go crazy or something. But maybe it has value, and if you have like very few, a couple of places where they're like this, like that might be a sufficient solution. But in this code base, it's often like there's a lot of Java-isms and a lot of like kind of closures, a lot of state, mutable state, a lot of kind of object graphs that depend, dependency chains that are quite long. So in that kind of environment, I think, you want to develop those power tools potentially.
Yeah. So you dropped hints earlier of a power tool you've been working on. Do you want to show us what you've got so far?
Yeah. Well, this is fresh off the presses. This is just an experiment this morning, but I've written a little function called X-ray, and so my cursor object here. Sorry, I clear this buffer here. My cursor object, you see, is just no print method on it or anything like that. If I X-ray that, then I'm going to get a map. If I just scoot up to the top here. So what it does is it kind of reflects over the object graph and makes transparent all of the different fields in the object as using Clojure.reflect. This is something like that people are doing Clojure code bases all the time. But it will try to make fields accessible and normal stuff. So this is like designed for dev time, right? You don't use this in production or anything like that. That's my intention. This is just a REPL tool that aids you when doing this kind of exploration.
Of course, the reason we need this is we have use of the Arrow Java library, right? So we can't treat that Arrow stuff with sort of higher abstractions. We have to drop down to the Java if we want the performance.
Yeah, I mean, often there is real needs that drive the mutable state and so on, and def types like, unsynchronized mutable fields, primitive unbox primitives, things like that. And then we are using the arrow libraries, which of course very mutable and very like kind of resource aware, like sort of semi-manual memory management kind of environment where you can't kind of get away from these objects, right? They're kind of everywhere. So yeah, it prints structures. So any object will be expanded out to its fields. Seekables will be walked, and you're kind of recursively kind of building up this map. Clojure maps returned as is, like all the kind of primitive things that are already transparent, like are not transformed in any way. It's only things which would be opaque. So yeah, the other thing it lets you do is addressing. So as well as walking the structure and printing or returning a map form, it puts these little ref keys on the map. And what you can do is, if you want to grab the instance, so I want to grab this leaf in this array here, then I can call that function there, and it will grab me that instance of the object, that exact instance, right? And then I can interact with that. I could like pass it to a function. I could like continue poking it. I could try and put it in a different state and see what happens. Of course, I could X-ray that object and get a narrower view, right? So really, this tool, like, it's about transparency, bringing to you like the information of the system. Like, I don't need to remember the field names or go and look them up or anything like that necessarily. I can kind of just see them. They're obvious. It puts these little addressing hooks in, so you're able to, without navigating again and like kind of having to write out like paths through this structure, which may change, particularly with arrays and things like, the position that you're interested in would change from call to call. You're able to directly kind of deref out the object instance. And that's the goal of this then, is to sort of try and reclaim some of the sort of Lisp interactive development experience, to have a better time in my comment block and kind of, be able to work incrementally and make small changes. I want to be able to, take these objects, which took a lot of setup, right? It took a lot of def, and open this calls, kind of get them in a state which is interesting, and then pass them to functions and see what happens, right? Or like put them in different states, see what happens, for that to be, interactive, quick feedback, all the good stuff, right? We value as Clojure developers. But it's a work in progress, and this is like fresh off the presses. So
yeah, no, it looks really neat. So I had one question, specific question: is that like a globally unique like atom counter thing? So it's like however many times you call this, these objects are sort of being stored somewhere.
Oh yeah. So to do this, you have to have some like global state, right? So nice. There's a registry, and you can. So there's a couple of calls. So there's like a clear call and a reset call. So clear all that's like free memory, but it keeps track of like the counter stays the same position. So like old refs they evaluate to nil, right? They don't return anything. And there's a reset call, which will reset everything back to how it was. But because it's a global registry, right, and it works with object identity, like the same object instances are going to result in the same IDs. So like the same ID is stable for that instance until you call clear or reset. So if I can reeval this as many times as I like, and I'm not going to get new IDs in here, right? It would take the object changing in some way, right? So the identities of the objects are different for that to change. But again, dev tool, right? Like I'm not targeting like production, like testability or something like that. I'm targeting, having a good time at the REPL and interactive environment where I want to make things happen with key presses. I don't want to have to thread things around. I don't want to have to like kind of deal with that kind of overhead, like cognitive overhead, so to speak. Like, so I think for interactive development, this kind of like focusing on the user, like the DevX kind of experience is sort of more important sometimes than worrying too much about sort of any kind of purity. So yeah, absolutely, just bangs on Atom. Right?
Brilliant. That's great. I mean, that's the beauty of the REPL, isn't it? So you can build your own tools sort of on the fly to suit the workflow and get into the space you want to be in. And it's not much code as well, right? It's in the repository now. You merged the PR earlier, so
yeah. I mean,
anyone wants to check it out.
A little scrappy, but yeah, it's I think it clocks in just over 100 lines, something like that. I mean, it's not a lot.
Nice.
So yeah, it's a little bit more. There you go, a comment block in there as well. So yeah, the it's not a lot of code. I mean, it's what you'd expect, right? So you know, walking objects recursively, tries to count for cycles and that kind of thing. But yeah, pretty horrible. But then you know, you build this once and you kind of put it to one side. Hopefully, you don't need to change it very much. So. Awesome. Yeah, right now there's no plan to make this a library or anything like that. I mean, it's like I said, it's very fresh. It may turn out to be a terrible idea in some way.
We will find out, and we'll report back. So yeah, thanks Dan for this tour and explanation of your REPL experience. So yeah, tune in next time. Yeah, thanks again. See you soon.
Cheers.